So here we are going to find the first derivative and the second derivative. So the second derivative is a higher order derivative. So the first derivative is f prime of x, which can also be written as f1 in parentheses of x, which says it is the first derivative, and the second derivative can be written as f in parentheses 2 of x or f double prime of x. So the first derivative of the function is, and notice that this is not an x, it's a function of x. It looks like an x to the fourth, so it's 4x to the 4 minus 1. But remember that the inner function is not an x, it's a function of x. So we go d by dx of 3x minus 5. So this is equal to 3x minus 5 the whole cubed times d by dx of 3x minus 5 is 3. So 4 times 3 is 12. 3x minus 5 to the third power. Now that's the first derivative. Now if we take the derivative of the first derivative, then that becomes the second derivative of x. So this is 12, which is a constant. We differentiate 3x minus 5 the whole cubed, so that becomes 3 times 3x minus 5 to the second power, and then we find the derivative of the inner function. So this becomes 12 times 3 times 3x minus 5 to the second power, and d by dx of 3x minus 5 is just 3 because the derivative of 5 is 0. So now we just simplify the terms. 12 times 9 is 108, and 3x minus 5 the whole squared. So this is the second derivative. If we want to find the third derivative, we can go one more step, and that is 108 times the derivative of this function is 3x minus 5 to the first power times d by dx of 3x minus 5. And this is how we keep going and finding higher order derivatives. And at some point, the derivative of a polynomial is going to become 0. It depends on the degree of the polynomial. So let's see. So this is 108 times 2 times 3x minus 5 times the derivative of 3x minus 5 is 3. So 108 times 6, we'll figure that out, times 3x minus 5. So this is equal to 6 8s are 48, 6 1s are 6 times 3x minus 5. Now if we take the fourth derivative of x, put the 4 in parentheses, and that says it's the derivative, it's not a power. So this is equal to 648 times d by dx of the function 3x minus 5, and that becomes 348 times 3. And that is 1944. Now the fifth derivative. Notice that we started off with a polynomial and we kept finding higher order derivatives, and now we are at the fifth derivative. And what we have here is a constant, which becomes 0. So if we differentiate a polynomial multiple times, at some point the polynomial is the derivative of the polynomial is going to become 0.